Welcome to this special presentation on how we can prevent catastrophic wildfire, presented by Scott Stevens. And let me introduce myself. I'm Dr. Vida Kenk. I'm the current president of Calaveras Big Trees State Park Association, which we normally just call CBTA. Let me go over a couple of things that are on your screen to remind you that you will be muted during my introduction and during Dr. Stevens' presentation. And then when we come to the question and answer time, you will be able to unmute yourself and ask by raising a virtual hand, by clicking the reaction circle, or putting your question in the chat. So just letting you know, you'll be muted for the first portion of this presentation, but unmuted for the question and answer part. And I wanted to welcome you very warmly. We are exceptionally fortunate to have Dr. Scott Stevens, a professor of fire science at the University of California, Berkeley. He has conducted research relating to wildland fires for more than 31 years. He's interested in interactions between wildlife fires and ecosystems and looking at the future, fire management, forest policy, climate change. Oh, he's a man of a lot of possibilities here. He is himself a certified senior fire ecologist, and he was awarded a Fulbright Fellowship in 2014. So with that as an introduction, thank you so much, Dr. Stevens, for joining us.
No, I'm thrilled to be here. I really am. I am. Giant sequoia mixed conifer forests are in my soul, frankly. I've worked on them for a long time, just like a lot of you. You're around them a lot. They mean a lot to a lot of people. So what I'll do today is give a presentation, hopefully about 25 minutes or so, 25, 28 minutes. I'm going to show mostly a few pictures and kind of hopefully generate some discussion. And then when we're done, I hope you'll ask some questions and maybe make some points. That's what we're here for. I always enjoy the questions. So let me just start here. Here we go. There she goes. Okay. So again, we're going to talk about kind of mixed conifer forests. I think that in some ways it is really pertinent to anything that you would think of as a dry conifer, dry ponderosa pine, dry Jeffrey pine forest. What we're talking about today certainly pertains to all of that. So how do you prevent catastrophic wildfire? Well, it turns out there is a picture right there. You can see that's a prescribed fire. We're doing a Blodgett Research Forest. Blodgett Forest is UC Berkeley's research forest in the northern Sierra Nevada. So done a lot of burning up there. So here you see some pretty heavy fuel loads. That place hadn't been burned. I think the last recorded fire was like 1897 based on tree rings. So pretty severe conditions. But as you know, we're trying to work to do some restoration, and what options might we have? So that's what I'm going to talk to you about today. I always like to show just a couple of photos or slides from some of the work that was done in the past. So here we got a quote from Shao and Kotak, where Shao and Kotak were a couple of foresters early in the Forest Service hierarchy that started to look at fire in California. So here's a publication, 1924. California pine forests represent broken, patchy understock stands worn down by the attrition of repeated light fires. I always think that that's just an amazing quote. Extensive crown fires are almost unknown in the California pine region. Holy Toledo. I mean, this is what they're writing about from their observations in the teens, really in the 19 teens. So if you remove fire for that long, beginning around 1905, and it certainly varies across the state somewhat, you're really going to change this system. And there's the little picture of the Bear Creek Guard Station on the Plumas National Forest, 1915. So a really open kind of upper elevation mixed conifer forest. I want to show just a little bit of data, because there's a paper that just came out recently. Malcolm North, a colleague, Forest Service researcher, did some work on some early inventory data. So those two areas are early inventory data, and you can see maybe on the upper right that one area is from the Stanislaus, the other one's from the Sequoia National Forest. Both these data sets were collected in 1911. before any timber harvesting and right at the beginning of really fire removal. And just suffice it to say, they're large data sets, 14,000 trees, complete inventory of quarter sections that were 40-acre quarter sections. So if you take that information and then think about, well, what kind of conditions were the forest in 1911, especially regarding competition between trees. Let's take a look at a figure here I want to explain to you. So there's a metric that foresters use called stand density index. Stand density index is essentially a way that foresters can look at competition between trees and then make management decisions to try to manage that competitive environment. So there are three kind of classes of competition when you look at stand density index. They're over here. Free competition, that literally is you're not competing with your neighbor, that your tree density is low enough that when you have drought, when you have kind of very dry conditions, you're in a condition where there's not many neighbors and you're not competing with your neighbor, so it's free competition. Then you go up to this partial competition. This is simply means you're starting to get more trees per acre, a little larger trees, and just beginning to start to feel the neighbor impact competing for resources, mainly water. The next one is full occupancy. Full occupancy really means that the growing space of that forest environment is filled up. And then when you get up above 60% of maximum density, that is classified as imminent mortality. So you're basically in a condition where there's enough biomass, enough trees per acre, that you're really on a cusp of a massive opportunity for mortality. So let's just look for a moment at the two data sets. We got one from 1911, and then we got one from 2011, 100 years later. So these violin plots on the left show you the condition of 1911, in the left piece of each panel. And take a look at that. In 1911, most of the trees in those inventories I showed you in the Stanislaus and the Sequoia National Forest were all below 35% occupancy, and a lot of them below 25%. For both mixed conifer, pine mixed conifer, xeric mixed conifer, a little bit moister, and then mesic mixed conifer or the wet mixed conifer. So one thing that this shows us amazingly is that about 1911, the forests were in a competitive environment that almost allow them to live without having competition with their neighbors, the neighboring tree. But take a look what the data shows us from the 2011. Now we see that the vast majority of the forest conditions in those areas are all either in full occupancy or imminent mortality. You're up in this other end of the diagram. In fact, it's almost completely inverted. We've gone from a competitive environment in 1911 when fire was still working, where you had most trees in a competitive environment that it really didn't even matter what numbers or their neighbors in terms of their competition. They were able to get water. They were able to fight off bark beetles. And then look what happened in 2011. We basically invert the whole thing. And then you look down here, 82 to 95% of the forests are either in full occupancy or imminent mortality in the Sequoia National Forest and the Stanislaus. Holy Toledo. That is a big deal. That's why we're seeing so many big mortality events like the one we saw 2012 to 2015. The forests are in a condition that basically full occupancy and also imminent mortality just from their density alone, let alone burn, let alone have a 4-year drought. So it just shows us, I think, what we're up against. We're up against a very difficult problem. I hate to say it, I call it a crisis. I think it has to be called a crisis. We've got forest conditions that are so difficult moving forward in climate change, it just magnifies the problems we already have. Now, this picture is sad. I've been working on the Castle Fire with a crew of mine, the Castle Fire burned in the Southern Sierra. And I spent some time with them this last year. And I have to say, it's one of the saddest days of my professional career. Walking around in the Alder Creek Grove and seeing things like that. Giant sequoia, completely consumed to the absolute top. 230-foot tree, probably 1,200 years old. And I walked around in that area from one sequoia to another, to another, to another, to another. They all look like that. Giant barbecue. Sad, okay? And I'm not trying to trivialize houses lost. My best friend lost his house a couple of years ago in a wildfire near Lake Berryessa. And I know it's hard when people lose homes. And I know it, and maybe some of you on this line have actually experienced that, loved ones too. It's a big deal. But when I walked around in these giant sequoia groves and just saw what this fire had done, it just shook me to my core. I mean, that tree had been there for 1,200, 1,300 years, probably experienced 100 fires, 200 fires in its history. And in 2 years, we've killed maybe 20% of them. The forest conditions at that site were set up to have a bad fire. That's just a flat truth. Probably 400 trees per acre, 40 tons of surface fuel on the ground. It was all gone. That's just my guess. But it's just a condition that when you get a drought, when you get some wind and you get a fire working that site, you can lose the entire ecosystem. And I think that's something that we're all worried about. It shook me to be down there walking around in that fire for several days. I just never saw that kind of impact to giant sequoia personally in my life. So what can we do about it? Well, the good news is there is things to do. Okay, now I want to show you some photographs from our Blodgett Forest Research Station. This is that place up near Georgetown, mixed conifer, about 4,000 feet. Giant sequoia doesn't live here except the planted ones, but it does have all the other species. So we're doing a restoration project. So we're starting in 2001, 2002. Conditions very difficult, no fire for almost 100 years. Partial harvesting that have occurred in this site for many, many years. And a condition that I think is very common in the mixed conifer zone throughout California. About 300 trees per acre, 350 trees per acre. You got surface fuels, at least 30 tons per acre. All that is deadened down and the leaf litter on the ground. And it really is, unfortunately, ripe for such a fire like the one I just showed you in the castle. So what are we going to do about it? Well, I'm going to show you two sequences of activities. The first ones are going to be using fire alone, prescribed fire to start managing this forest to try to reduce its vulnerability. So here's the fire, one of the pictures of one of our fires one night. And I just wanted to have a couple comments. We're burning at night here because relative humidity, temperature is better in this part of the world when we were burning at night. And we got to be nimble. You know, we just had a January, February that frankly was bone dry. And my goodness, could you have done a bunch of burning then? We cannot wait for the fall, 2-week period, maybe a dry spring. We all have to get better at using the opportunities that are dealt us. That means we burn when we have the conditions. One of my colleagues, Rob York at Blodgett Forest, he burns whenever he gets a chance. He burned probably a dozen times during January, February this year at 4,000 feet in the Sierra Nevada. And that's what's going to take because we've got some work to do. We got to be able to be more nimble. We need a workforce. The state's trying to get more people involved in this. There might be there will be a prescribed fire training center in California to help people get trained in prescribed burning. We also need political and public support to do this. We just don't have the workforce yet to do it. Of course, we want to create it, and I think we can, but it's going to take a little time. You know, it's not something, unfortunately, we can just flip that light switch and we're going to have prescribed fire going at the scale we want, but we can work at it and we need to, but we need to be nimble. When we get our chances, we go out and do activity. Now, the next picture, there's that big old sugar pine that you saw in the first photograph, okay? Take a look at that. That's after one fire. We consumed around 80% of the surface fuel. We killed about 75% of the trees 10 inches in diameters or less. That was the goal. We want to reduce forest density, right? We want to actually do some work with fire. Now, that's 2003. Let's go ahead a few years. There you are, 2009. You're starting to see some of those initial trees that we killed come down, aren't you? From just rot, wind throw, and snow. We see a Ceanothus integrimus deer brush seed bank response. We got some shrubs coming up that are native, no problem. So places change. What are we going to do? We're going to burn it again. So this is the second fire we put down, 2009. And there's that same tree that I showed you a moment ago. So our second fire, now you see we're burning in the day. It's actually the conditions of the fuels were sparse enough that we couldn't burn at night and get our goal. We actually had to burn under drier conditions. And this is after the second fire. So there you got that same big sugar pine. We start to see some of those killed trees are gone. They've been consumed. A few more standing. We see a couple logs on the ground. Some of the shrubs have been reduced, but we still see shrubs. What are we going to do? Let's go forward again. There's 2017. Again, we see more deadened down coming down from the mortality. We see the shrubs also responding. So what are we going to do? We're going to burn it a third time. So we burned it for the third time. This time another ignition in the day. Actually had the most heterogeneity in terms of fire behavior and also how much area burned, a lot of patches. That's after the third fire. There you see the surface fuel is about 10 tons per acre now. Surface fuel is about 10 tons. Tree density is probably down about 100, 120, probably still a little high, but it's certainly less than 400 where we started. The ladder fuels have been reduced, so we have far less ability to torch this stand if a fire comes in. And here's what it looks like pretty much today. So there's that same tree. We see some of the shrubs coming in. And you're in a mode now, if you're interested, you could just do maintenance. Maybe you work cultural burning, indigenous burning, prescribed fire, and work them together. But after the second fire, we were in pretty good business. The third one was really a maintenance fire. The first one, you kill so much that you have to follow up and do some work afterwards, okay? After that second one, you probably got some time, but those first two fires were key. And it turned out, if we go up here today, we really have a marvelous outcome and something that I think that we feel very good about. Of course, these are small stands. This is only about 50-acre stands. This is a research study. We need to make these larger if we want to do something at scale. You know, the King Fire just missed us. Remember the King Fire 2014 came out of the canyon there in Highway 50? It actually hit Blodgett, just barely brushed us. But had that fire come up and hit these stands, 50 acres, I'm not sure if that would have mitigated really the King Fire behavior. 100 acres, 1,000 acres, 5,000 acres, it'd have mitigated. Darn right it would have. But you just got to get a little larger in the way we actually want these treatments to be on the landscape. We did some work also on kind of the competitive environment. We see the tree ring growth in these trees actually be enhanced after the third fire, less competition between their neighbors, and a lot of other things we could talk about. We've probably written about 30 or 40 papers, soils, entomology, social sciences, economics. We've written papers all about this, and maybe we can get some questions about that in a moment. I want to show you one more sequence. Now we're doing something with machines, no fire at all. So this is the mechanical only treatment. Okay, so we're starting the same condition I just showed you before. Something like, 35 tons surface fuel per acre, 300 to 400 trees per acre. It hasn't burned since late 1800s. I want you to watch this California black oak over here in the right-hand corner. You see that tree that's kind of leaning in. That's going to be our focal point for watching this slideshow. So now we're going to do a restoration treatment with machines, with thinning, and actually watch what it does. So here's a masticator. The masticator was used to chew up trees that were below 10 inches or 8 inches diameter because we couldn't send those to the sawmill. We really need more options to use biomass in restoration in California. Maybe we can do something someday to create maybe a fuel, a liquid fuel, maybe other OSB wood panels. We need something to be able to use this material because just leaving it on site is just not really great. It costs a lot to process this way, and it doesn't really achieve some of the other outcomes maybe we like, carbon benefits. So we're all working, I think, to try to figure out how to get small wood utilization better in California. That will help us. Next picture shows there's that black oak leaning in, and you see the first treatment, okay? Right after the first treatment. Of course, tree density is down. You see a lot of tops and other materials left on the ground. The surface fuel was increased after this treatment, but the height to live crown or the ladder fuels were decreased. When we modeled this, it was a wash. So more surface fuel, but less ladder fuel. When we modeled wildfire here, it turned out to be not much difference in the initial condition. Not something to really shout about. But if you go, let's go forward a few years. There's 2003, there's 2010. There's that same tree up there. And we're starting to see some of that regeneration happen in the understory. This is one thing we always have to think about. Never ends, does it? Once you start these treatments, you've got to keep them going forever. I remember talking to Wayne Harrison up at Calaveras a bunch over the years. Wayne was a friend of mine. And Harold Biswell. Biswell was another person that used to work at Calaveras for many years. He was actually a professor at Berkeley from 47 to 1973. But Wayne had a fantastic program going at Calaveras. And he was a leader in the state in these activities. We just got to be able to get more momentum behind these. It's unfortunate when people stop being in places. Many times it's all about personalities. I hate to say it, but you find these great people doing great work. And of course they move on, in life. That's called life. And a lot of times we don't get the continuity because it's got to be more about just individual people doing the work. It's got to be institutional. It's got to be institutional. We all got to get behind this. Institutions got to get behind it too. So there's 2010. By 2010, 80% of that masticated fuel bed I showed you had decomposed. That was a shocker. I thought that stuff would have stayed much, much longer. dry environment, don't get much rain in the summer, just like most of California. But the material was so shredded by that masticator at high surface area to volume, a lot of fan fungi came in there and decomposed it. So by 2010, 80% of it was gone. And by this point, really good fire behavior outcomes in terms of wildfire behavior. The forest would actually do very well now if it actually was burned by a wildfire. Let's go forward a few more years. 2015, start to see a little bit more incense cedar getting larger here, right? Regenerating, just like you would expect. That's why these treatments go on forever. We have to keep at it. We can never be done. Next thing I'll show you is a second restoration treatment. So we did another mechanical thinning and we did another mastication, much lighter. And this is what it looked like after the second mechanical treatment. Some people would say this is a timber grab and this is basically destructive. You know, my view is when you do a restoration thinning treatment, it's all about what you leave. It's not about what you take. You go into that stand, into that forest, and you think about what do I want, species distribution, sizes, how they clump, how they distributed on the land. You focus on what you want to leave. Anything else is in excess, you can take. Some of that can go to a sawmill, some of it can't. Some of it might go into piles, but it's the whole focus is on what you want to leave. It's not a commercial system where many times you go into a commercial system, you think about how do I get out the volume the most efficiently? Then how do I regenerate it, grow it, and do it again? That's not at all what you do in restoration. Restoration is completely different. Go in there and think about what you want for climate change mitigation, fire into the future, and you think about a forest condition that you want to create with those machines that enhances that. And that's what we did here. So I think this one works pretty darn well too. It actually is sequestering the carbon from the atmosphere the highest. When we look at both we have another treatment, we have fire only, mechanical only. We also have a mechanical followed by fire. I'm not going to show you that tonight because of constraints in time, but this one is doing very, very well from carbon sequestration because of just the amount of growth that's happening on the residual trees. So that's one thing that's interesting about this one. By no means is this 100% surrogate for fire. It's not. But it does achieve some of those other outcomes of making a forest more resilient to the future and also resilient to wildfire. So I think the mechanical piece is another piece of the puzzle. I don't like the idea of just a priori taking all the options that we need off the table. We got such an issue going on. My view is we put all the treatments on the table and we try to make the best decisions based on our objectives and what we got going. So here's a summary that hopefully we can get some questions. You know, California frequent fire forests really do have massive problems. You know, climate change is an issue and it's real, but it's not the main focus. My view is climate change impacts to California forests are no more than 25% of what's going on right now. 75% is forest structure. The structure I just showed you. That structure is so vulnerable, and we're carrying it forward after all these decades, and now we're getting into an even more difficult situation when temperatures are up, weather's more volatile. We're into a drought right now. Of course, we've had droughts in California forever. But when you have that condition and you move it forward under those conditions, that you're seeing an instance now where it's magnified in terms of its vulnerability. But it's not the biggest part. The biggest part still is the forest condition. In some ways, that's good news because we can do something about it, can't we? We can do that prescribed burning, indigenous burning, restoration thinning in very remote areas. We can manage wildfire. I've been working on that at Yosemite for over 20 years. Had some great outcomes. That's only going to be in some areas where you have all federal ownership, probably a majority, and certainly no people. And of course, we're going to have a bumpy road when we start this up. But what's the options? Oh my goodness. I was in the Dixie Fire this year. Couldn't believe it. The Dixie Fire burned 960,000 acres, 51% high severity initial estimates, 51% high severity for the Dixie Fire. Of course, there's shrublands in there, and there's oak woodlands, there's other vegetation types in there, but there's a lot of conifer forest, and the Dixie Fire was just a giant, real difficult fire. State of California is doing some good work here. Initiatives starting with the Brown administration into the Newsom administration, California Assembly and Senate, passing laws, putting money on the table, creating a prescribed fire training center, something that's being discussed right now. I have to give the state credit. The state really has stepped up. The Newsom administration has stepped up. I wish it had started 30 years ago or 40 years ago with Harold Biswell. You know, the first year Biswell published a fire paper in California, pine forest, 1958. 58. And he started talking about these issues shortly thereafter. He was chastised. In fact, my former department and dean tried to get him fired off the Berkeley faculty. This is true. And he was forbidden to work at Blodgett Forest like I was by a senior vote of the faculty at UC Berkeley. This is not a lie. But Biswell, by the 70s, early 70s, there was a lot of evidence that we were on a track going in down the damn wrong road. But unfortunately, it just didn't change. Wayne Harrison and others started to buck the system, started to work. But we never really changed our kind of mantra. I think we got active stewardship. That's my view. Active stewardship of these lands are the only way we're going to conserve these into the future. Got the MOU, million acres treatment per year by 2025 annually. You probably heard about that. That's a nice, great goal, ambitious, but I think it's something that gets us on the way. I'm still a little worried about the federal side of this coin. I think I know a lot of people, a lot of my friends work for the Forest Service, and they really are discussing this at the highest levels, but I still do not see enough action on the ground. That's my view, okay? We need to do better. I think we got 10 years to start figuring this out. I hate to say it, but I think we got 10 years to start changing the trajectory of the way these forests are being managed, to get their vulnerabilities down. We're not going to get everything treated in 10 years. Oh my gosh, not. But we're going to have to change the way we actually manage our forests at scale. And I know some people might be upset about this, and I'll listen to them. But when I start walking in the Dixie Fire, I start walking in the the North Complex Fire, if I start walking in all those fires I told you about, the outcomes of those fires are devastating. They're going to be carried by our grandkids. They are scars on the land that's going to be there for generations. It's our job to work on the green forest to get them better condition. So when these stress come, we're going to be able to conserve the forest. That's my view. So with that, maybe I'll stop and be able to take, I'm happy to take any questions or anything else, please.
Thank you so much. And I hope that there will be lots of questions. What I'd like to do now is go back to that very first slide that talked a little bit about how to ask questions. But first of all, let me say in response to a question raised in the chat that yes, this is being recorded, and the recording will become available at a future date, which we haven't quite figured out yet, but we will make it available to the public, because I know not all of you were able to come. Actually, there are almost 80 people here, and I think that is wonderful. So I want to thank you for that. And so let's just remind you that you have at the bottom of your Zoom screen something saying reactions with a little smiley face. And if you touch that and go to the bottom, you will see that it says raise hand. And I see at least 3 people have already, 4. Okay, you've discovered that. That's one way. Another is to ask questions in the chat, which I have already mentioned response to one of them. And then eventually, if we just get too desperate, just, a lot, and I'll try to call on you. So those were the things that I wanted to say. And so let me see, the first hand that I saw go up is Nathan. And by the way, when you were called on, will you please unmute yourself and give your question, please? Nathan Mags.
Very good. Thank you for having me, and thank you to the professor. My name is Nathan Magsig. I'm actually a supervisor from Fresno County, and the Creek Fire happened in my district about 18 months ago, and it burned almost 400,000 acres. Yeah. And I think the severity of that fire was like 70 or 75%. Yeah. And what can we do? For me, it's a top issue as I deal with my residents in eastern Fresno County, the mountain community. But like you say, there are so many who aren't paying attention to this. And if I'm not mistaken, we only have about 30 million acres of forests in California. I know I'm running for Congress because I'm trying to bring a voice to a lot of these issues to try to get at forest management, local control. So what more can we do to try to wake up Washington to really what's needed here in California and the rest of the Western United States?
No, I hear you, Nathan. We just we actually wrote a manuscript on the Creek Fire. The Creek Fire is really an important one to basically understand better. We just got it back from Forest Ecology and managed it with minor revisions. We're actually trying to get it finished now and maybe resubmit it so people can see it. And I think, the creek fire to me really was set up by that mortality event. The 2012 to 15 mortality event. Some people would disagree, but our manuscript, I think, shows conclusively that mortality event created conditions we call for a mass fire. A mass fire is simply when you have high fuel loads all burning simultaneously over several square kilometers. And what it can do is it can create its own weather. And we actually show in this analysis on the creek fire that the day the biggest fire spread, that the wind speed, the external wind speed of the creek fire was within the normal range of variation for the last 25 years. So that fire was not wind driven. It was actually driven by the conditions of the fuel in the system. So it tells me, it screams that we need to do the treatment in the green forest today to reduce vulnerability. And I hear you about, I know right now there's a lot of excitement that we got the bill from Congress, the infrastructure bill to try to put real money into some of this restoration. I know a lot of folks on the Sierra. I know them on the Sequoia National Forest. There's a lot of good people there. But I do think, I think we're going to need some federal legislation to enhance it. I'm worried that if we just put that kind of money down on top of a system that's not working efficiently, that I don't think we're going to get the outcomes that we want. Maybe that's a little harsh, but I do think, the need for these active stewardships of these landscapes in the green forest. Now, the problem with the creek fire and also the Dixie is, what do you do now? And my goodness, is that a hard conversation? That is a hard conversation. I've been up there. I actually took Boy Scouts to Shaver Lake for many years in that Boy Scout camps there. So the options when you have that kind of high severity patch, as you alluded to, is so much more thin and so much more difficult. I would argue, and again, this is not going to be something that's going to be completely agreed upon. I argue, work in the green, put your effort in the green forest, reduce its vulnerability, then maybe work a little bit in the black. I worry that we work too much on the black, the salvage, harvesting, all the other things, reforestation, all that's needed. But I'd probably rather see us really start to work in earnest with that active stewardship in the green forest of the Sierra National Forest and get it going. Because if we keep chasing the black, you know what, we're going to be chasing our tails forever. So, but I am also very difficult fire in the creek fire and what it did. Horrendous, frankly.
Thank you so much. Aaron King, I believe you were the next hand up. Please unmute yourself and ask.
Hello, thank you very much, Dr. Stevens. That was great. Unfortunately, my background is in marine ecology and we don't have many fires in the ocean. So I really don't know too much about forestry fires. But here in Calaveras, along the Highway 4 corridor, we're putting a lot of effort into creating fire breaks.
Yeah.
Essentially, clear-cut areas so that fires can't get into some of the communities.
Mm-hmm.
What is the science? What does the science tell us about the effectiveness of such fire breaks? Are they successful? How successful, etc.? Thank you.
No, that's a very good question. And it's a challenging one a little bit. When I think about California and our human communities, when you think about the vulnerabilities of human communities, which I'm afraid are underappreciated because of just the vulnerabilities that are out there, I think it makes a lot of sense to start working at the wildland urban interface as one of the places that you're interested in, because you're trying to keep people as safe as possible, of course, their property and everything else, right? And one example we have right now, we're actually working on this too, is the Caldor fire. The Caldor fire, you remember, it was last year. It burned up through the Highway 50 corridor, then eventually went over the crest, Echo Summit, then kind of went down into Myers and South Lake Tahoe. One of the things that happened down there, this is what we're investigating. We actually are talking to the battalion chief officers and the line officers that actually took suppression actions as the fire crested over Echo Summit down to Myers and South Lake Tahoe. One of the amazing things about that particular outcome is not a single house was lost, a couple were damaged. And I think what we're seeing so far is the people talking to us that actually were on the fire during the full suppression event, they basically made use of those shaded fuel breaks or defensible fuel profile zones that basically were pre-installed around Myers and South Lake Tahoe. That they knew they were there, they could actually maybe take some stands in those things and actually try to keep the fires from the human communities. And I think Andrew Johnson, a PhD student in my lab, is working on this in earnest. So I think it shows that if you can do some of that work and actually have a suppression agency able to use it during an event, you can probably make some outcomes that are positive. It's not going to be a silver bullet. Some people say, well, just do that. Just all you got to do is work in the WUI, and then everything else is going to come into play. The wildlands are going to burn anyway, and we're not too concerned about it. I just can't agree with that at all. I think the wildlands are also incredibly vulnerable, and things like the creek fire and that mortality event that we talked about. But I do think if you do those shaded fuel breaks and other activities in conjunction with your fire service and do them at scales necessary, you can make a difference under some conditions. And, of course, the Caldor fire is pretty extreme. But we know Greenville burned down this year in the Dixie fire, right? The Greenville community got burned over. So, but I think it's probably a logical place to begin and have a conversation, and then use those shaded fuel breaks and those fuel breaks that you alluded to as anchors to do more in the landscape. They're going to be used strategically to anchor other activities, prescribed fires, maybe some mechanical thinning. Use those as anchors to go large. But I think the human communities are just probably one of the logical places to begin, but don't just stop there. That's my view, at least. Thank you for the question.
And I'm just taking a quick look at the chat. I'm sort of going back forth a bit. Did Paradise have fuel breaks surrounding it? Was one of the questions. And then the other thing is, are there things that our neighborhoods could be doing? So I sort of thought perhaps those two questions might go together. And there are going to be some interesting questions about cultural burning and indigenous burning as well. But if you could respond to, what can we do? I'd appreciate it.
Paradise did have some work around it. The city of Paradise, to its credit, actually was one of the communities that actually had live trials of evacuation. You probably know that. The board, the city council there tried to come up with a plan to try to figure out to get people out of harm's way. They never realized how fast that fire could move out of the Feather River Canyon and be on top of them. So unfortunately, the fire overwhelmed them much more quickly. And I do think also a lot of the community itself was so vulnerable. So many ponderosa pine in there, needle drape over houses. I'm not trying to be hard on anybody, but the community itself was also incredibly vulnerable to a type of fire like that. I think it's actually a great example of doing work at the landscape level and the community level to try to reduce vulnerability. One other thing I'll say about this is some work I've done in Australia. I've been to Australia a couple of times for sabbatical. And one thing the Australians do, and this is something you could do at Arnold, it could be someplace, you can do this anywhere. The Australians do a better job at getting their communities better prepared as small little units for fire. They call them little small battalions inside their community where they get together twice a year. They talk about the fire season. They talk about a neighbor over here that's 85 years old, doesn't have a car anymore. Somebody down the street just maybe had a baby, basically not very mobile. They actually talk to their neighbors and they create a plan that says, okay, if we have a bad fire, this is what we're going to try to do. Okay, we're going to make sure we take care of this person. We're going to egress over here. We're going to work on some of our evacuation routes. And they do this every year, routine. It's not to say everybody does it. In fact, they're worried because a lot of young people are bowing out. A lot of young people, they call them the gray hairs, are actually staying in and they're not getting the younger generation. But can you imagine if a fire is on top of you, is that the time to make a plan? No, it's not. You've got to make the plan ahead of time. And the University of California Cooperative Extension, there is some people that can really help with this. And this is something that there's 5 of these folks being hired right now just in the fire area up and down the state. And they can help facilitate some of these conversations and actually get people better prepared. So I think as communities in California, we need to make these local level plans. Fire safe councils and all these other things are doing good work. But talk to your neighbors as small units and try to figure out a way. If something happens, what are you going to do? Where are you going to go? How are you going to help your neighbor? Maybe you're going to reduce the vulnerability, the vegetation around your house. And you do that as a community. I think we got to do that at scale too, because that's another way that we can make our communities better.
Thank you. And Martin Huberty, I think yours was the next hand to go up. And I also see Utter and Mary and John, whose last name I probably won't pronounce correctly, and Tom and Brenda. So yeah, you're all in line. Just want to let you know. But Martin, it's yours now.
Thank you, Dr. Stevens. I had a quick question just regarding mastication and prescribed burns. I mean, when we can't be prescribed burning, how effective is masticating? And should we continue on as much as we possibly can? And I guess the second part of that is, I understand that mastication, you don't get the burning and the seeds don't open, but what is the difference between masticating and a prescribed burn?
No, that's a good question. One thing about mastication is, at least in the conditions I showed you, it's expensive. You know, when we were doing the mastication of Blodgett Forest, that condition that I showed you, maybe 300, 400 trees per acre, we were doing 2 acres a day with a machine running full on. That's the equivalent probably on the order of maybe $1,000 an acre cost. $1,000 an acre. You know, that's a lot of money. And can you imagine how much area we need to treat in the Sierra Nevada, and how many masticators would you need? You almost need like a beehive of them, right? So I think the mastication is probably going to be better for local places, maybe around communities where you don't have as many options, maybe for managing young forest stands that are highly vulnerable to shrubs and maybe high density. And I think it's just going to be a piece of that, but it's not going to be a big piece. I think it's just too expensive probably. And that's why we're crying out for some way that we can use this submersible material in a way that actually maybe at least breaks even, or some subsidy. Because that's a tough piece. I was just in North Carolina last week, of all places, and I was actually at a place where they were doing a lot of prescribed burn in the Southern Appalachian. And they actually talked about 6 different uses of biomass that they had right there. All the way from Steve mills to make their barrels for their whiskey and stuff, to basically pulp, to other activities. So they had markets that were able to use some of the material that we don't have. And that makes things like mastication then look like something we can use, because we have so few markets. And your question about it being different, it is different. You're not going to get that nutrient recycling of the upper, the mixed conifer, or the surface layer is not going to burn. You're not going to get some of those impacts of maybe smoke that can have some impacts to ecosystems as well. So it's not by any means a direct surrogate for fire. It's not a replicate for it. So you're not going to get those aspects of it. I think the one thing we all have to think about, though, is what's going on with the surface fuel. If you don't treat the surface fuel is a dead and down material on the ground. My view is it's 60 to 70% of the hazards of all the forests we're talking about. 60 to 70%. Unfortunately, it almost has no value, but there's so much energy in it. So it has to be the bullseye. The second bullseye is the ladder fuel, 25, 30% of the problem. Trees and the shrubs that can take a fire vertical. The overstory, no more than 5 to 10% of the hazard. That's just the physics. So whatever we do with our machines, whatever we do with our activities, we've got to reduce surface fuel. That's one thing we've got to do.
Thank you very much.
Thank you. And Utter, what is your, please utter your question.
Mm-hmm.
Hello, Utter's iPad?
Ooh, we lost him.
Did we lose Utter's iPad? Well, having tried for a few seconds, yeah, Mary, let's go on to you then, please.
Good evening, Professor. Thank you for being here today. I love how you completely encapsulate the idea of forests are all around us. You love the forest. You spend a lot of time there. We're Californians. We live here. I don't think we're going away anytime soon. There are a lot of people wanting to move to the Sierra Nevada for all kinds of reasons. So unfortunately, here we are. And so we need to have some real human solutions to our problem. Yeah. So I'm thinking we love our CAL FIRE firefighters. We really do. We love our local district firefighters. They fight fires. They're really trained well. They love their jobs. They work hard. But we probably need a non-firefighting organization or apparatus to turn over the type of thinking that California's had for decades and decades on what to do about fires in California. What do you think about maybe like a California czar, or someone that reports to Newsom, or someone who liaisons with the federal government to really take it from the top level and do some serious pushing?
No, Mary, you're right. I think we need a workforce dedicated to this activity that I think you allude to. Just as an example, last year, of course, was a huge fire year in California, right? A lot of my friends work in fire suppression, people that I've worked with over the years. I think if you work 40 hours a week and you do that for 12 months, it's 2,048 hours. I think that's the number, about 2,048 hours total. You know what? Firefighters last year, in 6 months, they had 2,200 hours. So they're working like 80 hours a week through the entire 6-month period. This was routine last year. So some people say, well, it's just maybe we can get the firefighting crew maybe to do the work we need. We can just hire them longer, somehow get them, into the restoration phase, as you alluded to. I talked to quite a few of them. I haven't talked to all of them by any means, but most tell me they're exhausted physically, mentally, that they really just couldn't do that, for a long period. So I think like a California Conservation Corps, some group of people that might be dedicated to this idea of restoration, stewardship, and doing that little independent from fire suppression might be exactly what we need. Because I'm afraid if we keep waiting for those opportunities to use the firefighters to try to see if they can cross over, of course, some of them can, and probably some of you right on this call do it. But we need this at scale. We need to be nimble. I just chatted about January and February. How many people in fire are actually hired in January, February to work in this state? Almost zero. Okay, that's not the wildfire season, right? So we just don't have the people. But if we had maybe a group of folks could actually organize and do this burning at scale that actually were nimble, moved around the state, we could get this work done. So I think we probably do need some sort of independent group of people that actually could do this work. I know it's being talked about in California, being talked about a little bit in Washington, D.C. D.C. seems to be thinking more about getting firefighters better pay. They need it, base pay, and maybe full-time status and some of these other things, thinking that they could take it on. I'm afraid from the folks that I talk to, that may not work.
Well, thank you very much. John, whose last name starts with an H, it's your turn, please.
All right, Heisenbuttle, don't be afraid of it. Scott, very nice presentation. Appreciate your passion. Appreciate you pointing out how important shaded fuel breaks are. Shaded fuel breaks saved Amador County this year from the Caldor fire, at least the communities around it. Question I had is, what's the difference between the prescribed fire on the Blodgett Forest and cultural or indigenous fires?
That's a good question. No, John, that's a really interesting question. The last 4 or 5 years, I've been able to teach a lower division class at Berkeley, Fire and Culture in California. It's got a longer name, but I've been co-teaching it with an anthropology professor, Kent Lightfoot. And one of the really amazing things is that we brought in 4 to 5 indigenous leaders to talk in the class over the years. And they've come in and talked to us about burning. I've actually burned with Ron Good. Maybe some of you know Ron Good. He's actually North Fork Mono chairman down outside of Mariposa, does a lot of burning. So when I burn with Ron, and I've done this several times now, it's really interesting. Ron and Val Lopez, he's the Ama Mutsun chairman, and a few other of these indigenous people that I've gotten to know. When I show them the pictures I just showed you of my prescribed fires, I just showed you, they call it industrial burning. They actually call it industrial fire. They say, Scott, you do an industrial prescribed fire. I go, really? What's that really mean? I don't know what that means. And when Ron burns down in Mariposa, when I work with him on some ranch lands, sometimes he's burning sour berries. Sometimes he's burning, other berries for specific purposes, elderberry, oaks. He's working around oaks. He does a lot of pre-treatment, tremendous pre-treatment on doing a mechanical manipulation of fuels, getting them kind of configured where he thinks he can burn and actually meet his objectives for keeping the plant healthy and vigorous, top kill. So I think the cultural burning could actually be a component of prescribed fire both ways. You could do both. I think you could get tribes, if you were interested in, to maybe work on bear grass or other plants that are so important to them. They could tend them, they could actually do their cultural burning. Then maybe a larger prescribed fire could encompass a larger area. And then certainly that prescribed fire could give benefits to the cultural area by reducing wildfire severity. But my experience with cultural burning is relatively small areas. We burned with Ron Good, in a single day with maybe 20 of us, less than an acre, because it was so intensive of how he was doing the preparation and burning for the needs of the tribe. But I still think that complements some of the work that maybe I do at larger scales, and we could work together. I think the idea of indigenous burning is one carrot that we have that might really help, because I think when I talk to students in that class I told you about, a lot of students are coming from urban areas, like most of the population in the state. You talk to them about fire ecology, I talk to them about forest restoration, they're kind of interested. You know what? When an indigenous person comes in the room, holy Toledo, did they get excited? It's a way I think you can communicate also to urban people much more differently. I think it's just a way that captivates the idea. And they talk about active stewardship, active stewardship. Every indigenous person I talk to has some idea related to active stewardship of land. I think that fits in perfectly what we're doing. And I think it might be a way to get more people in urban areas maybe into this space, but that's just my idea.
Thank you. Tom, your hand went up next. And then after that, Brenda and Marita and Rich.
Great. Can you hear me?
Yes.
Okay. Thanks, Dr. Stevens. A question about the methodology of burn piles and getting rid of them, burning them. It seems to me in a recent Zoom meeting, it was stated that there are approximately 10 to 11,000 burn piles at Calaveras Big Trees Park.
Wow.
And so that's over a 6,500 acre area. So, and it seems that they're not being dealt with timely. How could you have, if they were, how could you have a buildup of 11,000 burn piles? I mean, that's absurd. So why can't they cover these piles and wait for winter and keep those piles dry? And then when there's good humidity in the air and it's good conditions, light them up. You're not going to, and the chances of a wildfire occurring from those are going to be less because of the conditions. Why is that not being done?
No, you're right. You know, that's a lot of piles that you just described. That's a tremendous number. And I know that, that's all over the national forest in California. It is one of our outcomes of doing field work and not having a biomass market or something to do with the material. A lot of places I've seen where they put butcher paper on top of some of those piles, the butcher paper, a little bit of wax on it. And the butcher paper is really good at keeping precipitation out of the center of the pile. And I've burned piles in my career, like a lot of you. And a lot of times, snow starts to go and you're into a nice storm. Once you get some good precipitation on the ground, you can go out there with your drip torch and start burning piles and ignite underneath, those areas that have the butcher paper where it's dry. The only challenge with any pile burning is if you go into a January or February like we just had, right? If you go into that dry period where you think you've got a period where, boy, you've got a nice moisture, nice area, and you're doing those pile burns, you get the bigs burned out, and then the fines don't dry, they don't move. That just means you're going to be monitoring these things and actually taking action as necessary. But I don't know what else better you could do than maybe cover them a little bit and then under conditions start to light them and then continue to do so. And it won't be risk-free, but having that many piles also is a problem with surface fuels, just like we alluded to. They're going to be more pointed points, but they've got to be dealt with somehow. So I think you're right. You just take the best you can and go forward in these winter periods and start that burning. And, then you basically work. And if you get into a dry period like we did in January and February, you're going to be building some line because you're going to have to take some action. Right.
And so recently we've had 3 or 4 or 5 days of pretty good rain.
Mm-hmm.
So would that be enough of a moisture to create an environment to do this kind of thing?
I think it probably more smaller scale, because now we're headed into that, late spring, early period, right? So we're heading to dry. Yeah. I love to have done this much more on the other end of the winter, probably more like December, January.
Right.
Even that's not without risk, but I think, I would certainly, you can do pile burning right now, but you're going to be doing a lot more monitoring on those things because we're headed to the warm period, right? But I would do it in earnest when that winter starts. And, nobody forecasted a January, February, right, that we had. That's impossible to forecast, and it's something that gets our attention. But I don't know what else you can do with those piles unless you got to burn them when it's wet and get them going, and then hope for some rain and hope for some snow. They burn out, and eventually they're over.
Great, thank you.
Okay, thank you. Brenda, it's your turn now, and then Marita, and then Rich. And the other thing I wanted people to think about is, would you mind if we have to go 2 or 3, a few minutes over? Because I'd really like to get all your questions. And Dr. Stevens has generously said he'd stick around for them.
Sure, no
so,
problem.
Brenda, go ahead.
Oh, hello. Thank you, Dr. Stevens, for being here today and doing this talk. So I'm associated with Friends in Elder Grove. We're just south of Yosemite and north of Oakhurst. And in 2017, we had the railroad fire come through. We originally historically had 299. At that time before the fire, we had 101 mature trees left. After the fire, we now have only 60 left. So understanding how to manage these fires is very important to me. So I'm really trying to learn and visit places. I'm actually visiting Calaveras Grove starting this coming Friday. My question is, and I'm wondering if there's any way to find out if some of the protections that we need for the forest and fuel management, how much of the forest is being sort of held in limbo by litigation? Is there any way to find out how much is being held up to protect the forest?
No, that's an interesting question, and I think you're onto something, at least I think Calaveras is still much more nimble in the ability to get work done because it's, it's a state park, a little bit smaller. You think about the Sequoia National Forest, the Sierra National Forest, these huge enterprises. Of course, this is all under NEPA, the National Environmental Policy Act, where we do, analysis, people do analysis and do these, try to understand what they want to achieve, and then they vet it to the public because this is a public process. And I think in some ways that's difficult because, I've seen so many of these, like the Elder Grove and others, where you're trying to do good. You go to the Sequoia National Monument, and you talk to the folks down there, they're passionate about this stuff, but still, you look what that fire did that I showed you earlier, the Castle Fire devastated, the Sequoia National Monument. And I think in some ways we're so risk adverse. I guess that's my opinion. We think that, maybe we're going to harm the Pacific fisher habitat, which by the way, now is, it's not in danger. I think it's, it's listed under the environmental, the ESA. So I think we get to the point where we're looking at more of the kind of the vulnerabilities of all these aspects, but we don't think about the vulnerability of the forest on top. I think the vulnerability of the forest has to go to the top. I don't know how do you have clean air, clean water, and endangered species habitat if you don't have a resilient forest? So I think it just tells us we got to be a little bit able to take a little bit more risk and allow our public officials to maybe take some more risk. And whether or not NEPA allows that, I'm afraid I can't answer. I don't know enough about that world and the planning environment. Maybe someone here does. And I know NEPA is important because we're a public, we are a democracy, public institutions, people have input. But I worry that we're not able to do this work efficiently and nimble, and still we start to see these fires going out the window. And I worry about just that trajectory. I think we have to do better. Maybe I didn't answer your question that well, probably.
That's okay. Thank you.
And Marita, it's your turn next. And I want to point out that Marita is on the Calaveras County Board of Supervisors representing District 3.
Which means the Ebbets Pass corridor and state park. The federal government's considering legislation to put out all fires on the forest. I'm interested in your position since we have at least up here numerous lightning strikes where we could have many fires going on at the same time. I'm sure you're familiar with what's proposed. Thank you.
No, it's a great question. I know I saw Congressman McClintock as I'm talking about this with some colleagues, right? And I know, we had the Tamarack fire last year that, people are very interested in, to say the least, right? It burned in Alpine County, threatened the board, the town, Markleysville, everything. So, and this is hard. I can say we could go today, well, maybe not today because there's a little snow, but there are places you can go in Yosemite National Park. One place in particular called the Illilouette Creek Basin. Illilouette Creek is a tributary of the Upper Merced River. It's almost directly behind Half Dome. If you're sitting in the valley and you look up at Half Dome, you look behind Half Dome, that really is the Upper Merced watershed and also Illilouette Creek. And Illilouette Creek is inside the park. It's completely, inside the park wilderness area. And they've been allowing lightning fires to burn there with management heavily since 1972. And it's a place we've worked now for over 20 years. I've even got a summary document on it. I'd be very happy to share it with you. It just talks about the work that we've done out there. And amazingly, this place now, when fires burn in Illilouette, they self-regulate. They actually self-regulate. We found out that if another fire comes along and hits another area that it burned, and if the interval of that period is 9 years or less, so 9 years, 8 years, 6 years, where another fire comes along and butts against the other one, 95% of the time it goes out on its own, goes completely out on its own. And this has been going on there for decades, okay? If once it goes over about 10, 15, 20 years, burns right over the top. But one thing about Illilouette too, which is so interesting, you know, a lot of places in California, we've been talking about like the Dixie fire, the other fires where we're getting higher and higher severity. We're getting larger and larger patches, like the Creek fire that was alluded to earlier, where we have these huge patches, tens of thousands of acres continuous that are all dead. That's what we're most worried about because it's so hard to get a forest to regenerate after that. In Illilouette Creek, of course, Illilouette Creek Basin is only about 45,000 acres. Okay, so it's not as big as that landscape. But even in climate change, even when all this is happening, there is no trend in severity increasing in Illilouette Creek. Those fires are basically they're no difference in the 70s, 80s, 90s, 2000s. We're seeing the same partitioning of severity classes because the fires work in the land. It's working that land, and we're seeing really what we probably would have seen if we had a time machine and went back 350 years ago and just popped down somewhere in the Sierra Nevada. So when I listen to that legislation, I think it's hard, but I think there's got to be a little nuance. If you're in a wilderness area where you don't have people at risk and you do have a year, I wouldn't probably do it during a drought, not the first one. You know, if you've got basically, you know, areas that have not had fire for 100 years, and then you have a lightning fire, maybe in a wilderness area that seems to be going okay, but you're in the middle of a 2 or 3 year severe drought, probably makes sense in my view to put it out. But if you're in maybe some period of just average precipitation, you know, like hopefully we're going to head to pretty soon, I think you can allow some of those fires to burn. They'll do work for us. They will do work for us, but they're not going to be without risk. Every fire I've been on is risky, you know, but the problem is there is no risk alternative, right? So I think that doing that in some areas, you know, the Highway 4 corridor, there's some areas up there, you know, the McCollum Wilderness, some other areas that maybe could be looked at carefully. And some of that work probably could happen. But I probably would try to do this certainly with planning with the Forest Service and people, stakeholders. Probably would not put my first fire into that territory during a drought. It's just not the conditions conducive. But I feel that in some instances, it probably makes sense, even though it's not easy.
Thank you. And of the hands I see, Rich Farrington, you're the last one. And then there are a couple of things from the chat I'd like to pick up. And in particular, what's the effect of managing forests on the watershed and increasing water? Okay. So Rich, where are you?
I'm right here. Thank you very much, Dr. Stevens. You showed pictures of some black giant sequoias killed all the way to the top. We have some people that environmental groups, I guess, saying that thinning the forest is bad, makes fires worse. I just wondered, this group is really focused on the Calaveras big trees and wanting to preserve and protect those. Is there something we can learn from the fires around the giant sequoias in the park, and the last 2 years of fires that killed over 14,000 giant sequoias over 4 feet in diameter?
No, I think there is. You know, I'll mention my colleague again, Rob York. Maybe you could get Rob York to come talk to you someday, because Rob loves giant sequoia. He's a colleague of mine in UC Berkeley department, same department as me. Mountain Home State Forest. So Mountain Home State Forest is in the Southern Sierra. It's actually, it's the largest grove, I believe, of giant sequoias anywhere, the Mountain Home Grove. Most of it's inside the California State Forest called Mountain Home. It's actually a demonstration forest for CAL FIRE. The outskirts of it are actually in the monument, the Sequoia National Monument. And the fires we talked about a minute ago, you know, the Castle Fire burned into Mountain Home Grove. And they're actually part of my dissertation a long time ago was actually doing some group selection silviculture in the Mountain Home Giant Sequoia Grove right there at Mountain Home State Forest. And Rob and others have basically taken that work and continued to work with it. So one site's called the Rock Crusher. The Rock Crusher used to be the site where they actually used to crush rock and make gravel for the roads at Mountain Home. And it just turned out to be one of the areas we worked. And they had the drought down there, the 2012 to 15 drought. They actually went into that giant sequoia grove and they salvage harvested most of the dead standing trees, most of them, not all of them. They cut them down and then they pile burned the residues. And then they actually did some underburning along with the piles. So they went in there and they removed some of those big old giant sugar pines, big old white firs that died during the drought. And then they also underburned it afterwards. And lo and behold, there was another site that I worked on. They didn't do that. They just didn't do that. They basically didn't do the burning, didn't do the removal of big trees. And both of them got hit by that castle fire. Rob's been down there. He says, when you walk on that line between the Giant Sequoia Monument and Mountain Home State Forest on the Rock Crusher Grove, you go from a barbecue, unfortunately, with the big old sequoias, and within 50 to 100 feet, trees are basically green. So I think that there really are some places you can go today and you could see that outcome. And, and Rob's so decisive, he says, that treatment they did made a world of difference, that the sequoias inside that Rock Crusher area are all alive. And, and it looks wonderful, he says. I haven't been down there in a number of years. And I have heard the same folks that say, you bring machines in here, they're unnatural, you're going to cause soil damage. That study I told you about with up at Blodgett, we measured soil compaction, we measured things like soil fertility, and we didn't find any impacts when that was done with care. You're not going to be out there with machines when the soil's wet. You're going to be doing it during the dry season. So the fire and fire surrogate study at Blodgett, I think it shows us conclusively that the treatments implemented as they were are not destructive. And if you work on those surface fuels that we talked about a minute ago, and you keep those surface fuels down somehow, hopefully not just by pile burning, but maybe there's another way you can work on them, the literature will say you're doing good work. And those folks that say it's destructive are wrong. Okay, that's my view. I think that's the science view too, 95% of it. So, I really feel that that's the case. But Rob has described that Rock Crusher site that had that treatment, the prescribed fire, and also the little bit of salvage logging when we had the 2012 to 15 drought. He says that's one of the most uplifting things he's ever seen. And that's pretty interesting. I think for me, Calaveras could use the same treatments. Is the politics available to that? Can they use machines? I actually don't know. Is there groups around that think that that's detrimental and terrible? I don't know. But I think the science is clear. The science tells us if you wanted to do that in Sequoia Grove, you could do it. And I might ask, Rob York could tell you even more about this if you wanted to invite him someday.
Well, thank you. And I want to say that, yes, we intend this to be the first of a series of seminars. I want to pick up a couple of things from the chat. And thank you so much, those of you who are hanging in there. Basically, one is our most important forest product is water. Water yield generally goes up with prescribed fire. Could you comment on this kind of thing, please?
No, that's another subject near and dear to my heart. The place that I can talk about that is Ilwet Creek. So we're headed back to Yosemite. Okay. So Ilwet Creek is a tributary of the Merced River. Of course, the Merced River is the river goes right through the valley, right? And just by chance, there's a gauging station on Illilouette Creek and the Upper Merced River right there at Happy Isle Gauge. I bet you a lot of you have been to Happy Isle down there in the Yosemite National Park, right? There's that little ranger station there. And there's a USGS gauge on the river there. And what we did is we asked the question about whether or not that wildfire reintroduction, managed wildfire in the Illilouette Creek Basin, is there any hydrological impacts? And the reason is we started working there around 2001. And then I'd been out there quite a bit, putting in plots with Brandon Collins and a bunch of folks who I work with. And then there was a Hoover fire. The Hoover fire burned pretty big, pretty large fire for Illilouette Creek, actually burned several, I think maybe 8,000 acres. I'd have to look it up. Of course, that's tiny compared to the fires we're talking about, but it was a pretty big fire for Illilouette Creek. And I remember afterwards, we actually had some plots in some areas that burned with high severity. So we went out there to remeasure. And all of a sudden, I remember being in a lodgepole pine kind of white fir forest, just a little higher elevation than Calaveras, kind of the upper mixed conifer, Jeffrey pine, red fir, white fir, lodgepole, aspen. So I was out there with a crew, and all of a sudden I'm walking in 6 inches of water. I'm going, wow, this is kind of crazy. I remember being here a couple of years ago. This is a dry fir forest. What's going on? So I actually invited some hydrologists to start working with us. Sally Thompson in particular, who Berkeley professor. She actually went back home to Australia recently. So she took a job in Australia, Western Australia, University of Western Australia in Perth. But Sally worked out there for about 5 years with her grad students. And what she found out was frankly amazing. So if you look at Illilouette Creek, that's had about 40 fires since 1972, and you look at something called a runoff coefficient, the runoff coefficient is the amount of water leaving a stream water per unit water in either snow or rain. So you just do a calculation of trying to do as best you can with meteorological data. You have that stream gauge. You also can model this with some hydrological models. And Sally and her grad students found out that from 1972 to the present, Illilouette Creek has slightly increased overland flow out of that basin, slightly increased. And she also did some work in some areas outside of Illilouette Creek in the National Forest, same elevation, same parent material, soils, same vegetation. All those places had no fires in the recorded history, even today. And she also had rain gauge stations there, or excuse me, stream gauge stations there, and she did a calculation. Every one of those places, runoff coefficient decreased since 1972. And what's going on in Illilouette is small gaps are being created that actually can hold snow. So having high amounts of canopy cover certainly intercepts snow. We all know that, right? Snow's on top of the trees. Climate change actually makes temperatures sometimes in the winter warmer. Sublimation, where you take the snow and go directly to the atmosphere, is actually really enhanced by warm temperatures. So as you get into more and more warm temperatures and more snow on that canopy, that water is not reaching the ground. But in Illilouette, since the fire's been in there working, we've got patches of maybe 1 acre, 5 acres, 10 acres, where all the trees have been killed. And they turn out to be really good places for snow to be deposited and the adjoining trees to shade it. And Sally and her colleagues showed that these snow patches, small gaps in the conifer forest created by high severity fire at small scales, 1 acre, quarter acre, 5 acres, 10, were really important to the snow dynamics of that basin. So I think this is a place where we really could get some synergy. We could actually create a more resilient forest ecosystem for the future, and also potentially make our water resources more reliable. I don't think it's not going to be a big bonus in terms of output, but it's not going to be negative. It'll be actually at least holding our own for our water resources with a little bit more. And actually that falls right in line with actual forest resiliency. The one other thing I'll say about that, and another question I'll be happy to talk about, when you go to Illilouette Creek Basin, it's messy. You know, those managed wildfires, they kill things. I brought a lot of, if you just go to the Mono Meadows Trailhead, all you do is take the road to the overlook, you know, on the south side of, on the south side, not Glacier Bay. There's that great overlook we all go to. Oh my goodness, what's it called? You know, the overlook on when you go past Wyona and you go out on that dead end road, right? And it's not Glacier Bay, Glacier Point. I don't know what it's called. I forgot. But there's a Mono Meadows trailhead on the way out there. You stop there and you hike in, you're in the managed wildfire area in 2 hours. And if you go out there with a backpack, like I have for many, many times, you can spend days out there. But you'll see dead trees, you'll see areas regenerating with live trees, you'll see logs on the ground burned up, and you'll just see what fire does when it actually works a forest. And most prescribed fires I've ever seen are much, much, much more mellow than that. You're not changing the forest condition as much as what's happened in Illilouette. Illilouette, in fact, you know, one of the papers that Gabrielle did in 1970, just by luck, Yosemite National Park did a wall-to-wall black and white photograph of the entire park, a bunch of mosaics, right? We were able to get those photographs, and Gabby did an analysis. The last fire based on tree rings, we actually did a fire history right at Illilouette Creek. We took chainsaws in there and took out fire history samples out of the trees. The last fire recorded in tree rings in Illilouette Creek, 1878. Why it stopped so early is another interesting question. I think it was partly indigenous burning. And then the next fire that burned was the 1974 Star King fire. That was the first fire that the Park Service allowed to burn, lightning fire in there. 100 years between those two fires, 1878, 1974. So in 1970, when they took that black and white photograph, the forest in Illilouette Creek outside of the granite outcrops is wall-to-wall trees. It is wall-to-wall trees. It's no different than we just talked about for a lot of those places like the mixed conifer at Calaveras. It was 100 years of fire out and the trees took advantage. You know what? As about 2012, 2013, when 40 fires were in there, burning and mosaicing in there, the forested area was reduced by 22%. I'm not talking about forest thinning. I'm talking about forest being transferred to a meadow, to a shrubland, or a wetland. 22% of that area is non-forested now. It's changed that place dramatically, but it's beautiful. So I'm afraid if we do these small prescribed fires where we maybe kill 10% of the trees or maybe 25% of the trees and we still keep the overstory, I just don't think we're going to see those hydrological benefits. At least that's what Illilouette tells me. Illilouette tells me that we really see change in vegetation. We're seeing big time change, still gorgeous, but we're not doing things, I think, probably in the other part of the world, mechanical thinning or restoration, maybe prescribed fire, anything close to what Illilouette's showing us. Illilouette is showing a dynamic landscape that's changing. And 22% of the area is now not even forest. It's a different vegetation type. So maybe that's just so I'm excited about that because whenever I talk to Sacramento, we talk about water, generally a lot of people really get excited. So I think it might be an integrator. I really do. And if it's something that we want to do more in our landscapes, it tells me that our treatments that we need to put on the ground have got to be more intense than probably what we're thinking about.
Yeah, I'd
be happy to send that. We have a summary document of the whole thing. So if anybody wants, I can email that to one of you here, and then they can be shared with anybody that'd like to see them.
Okay, and I want to remind people that we will make this recording available at a later time. A couple of other questions that I took a look at from the chat, and I don't know if you want to comment on anything because we're approaching the 20-minute after mark, is about homes being built more and more into the forest. And we do have the clear defensive space around these homes, but the vacant lots are not cleared necessarily, and whether they also need some attention. And then the other question about is the conditions that are needed for prescribed burns, what those are, and are there circumstances where dead and live fuel loads are just too high for prescribed burning? So perhaps if you could comment on those, and then I have a last little thing to tell you about some upcoming events at the park. Okay. Thank you all so much that are hanging in there, by the way. At least we've got more than 60.
You know, I think the question is a good one about your, you know, the vacant lots and you're doing your work and maybe your neighbor's not. I'm afraid what goes on in your neighborhood is a big deal. You know, you could do a lot of good work on your own scale, and a moderate fire, you know, it's going to make a difference. Your neighbor, unfortunately might lose their place, and probably you don't, because you've done that work, you know, at your scale of your lot. Under more extreme conditions, you know, more severe winds, maybe a drought condition, I'm afraid your neighbor's lot may overwhelm what you do. So that really does get at the question that it has to be holistic. And it's got to be both inside the neighborhood and along that boundary line where maybe the Forest Service is over here, maybe the Park Service. Got to work together. You know, the embers is all about the ember attack. The ember attack are just all those embers being thrown forward from the flaming combustion, right? All those sparks. And those sparks are notorious to try to basically find places of vulnerability and start another fire. Doesn't matter if it's a wood shake roof, or if it's a bunch of pine needles on your roof, or if you've got a ponderosa pine stand 100 feet away that's basically falling apart and there's needles everywhere. Those sparks are going to find that vulnerability. So you've got to be able to work on all those things simultaneously. So working with your neighborhoods and trying to do that work is paramount. You know, it really is. And then the last question is idea of prescribed burning. How do you get it done? You know, you're looking for these windows of weather. I've done about 130 prescribed fires in my life, less cultural burns and actually fewer wildfires. So my side on the wildfire side is actually much less than maybe some of you even here. I've been all types of fires, but you're looking for those windows of weather. You're looking for relative humidities, 40%, 50%, 60. Then actually the ability for those embers to start new fires is so low, amazingly low. 30% relative humidity and below, look out. Then you're going to start to see such a reactive fuel bed that you're going to get spot fires on it. So you're looking for that weather, and then you're looking for your ignition patterns, the way you put fire on the land. That's the two things you got. The weather, and then the way you put the fire on the land, and then taking opportunities when you have that. And I think that another thing is we probably need to work with the wildfire mosaic. That wildfire mosaic is pretty tough, but in some places you could burn right next to it. It probably won't burn for another 5 or 10 years after the bad wildfire. And you could burn next to it, use this as an anchor, and then continue that work. I wish we had a mosaic of forest ages out there already, like Illilouette Creek has, or indigenous burning had in landscapes meant long ago. I'm afraid we start with the most difficult fuel condition because a lot of it is continuous and high hazard. So that means we probably try to take advantage of some of these discontinuities, like maybe from a wildfire, certainly from other activities, and we burn against it. We start to do that mosaic. We get nimble. We burn in January. We burn in February. We burn when we can. And again, my colleague Rob York, holy cow, can he talk about that? He's probably one of the most nimble burners I've ever seen in California. So I think it just means you take the cards that are dealt you. You need that workforce, right? You can't have no workforce and get this done. But I'm afraid that's the only way I know we're going to go forward.
Oh, well, thank you so much. And I want to thank our tech people, by the way, Sue Hoffman and Debbie McGee, who are employees of Calaveras CBTA. And Sue, if you could give me the final slide, share that on your screen, I would appreciate it. What I want to say is please send us your feedback. This is intended to be the first in a series of educational seminars. So please let us know what worked for you, what didn't work, what improvements you'd like, what additional topics. We are looking at that. We have a committee that works on this and is planning. Actually, we're going to meet tomorrow morning to sort of see what went on this time. The recording will be available at a later date. Please check the CBTA website for the link once we sort it out. And I want to comment on 2 in-person events, seminars that are coming up on this Saturday at Jack Knight Hall, Science and Conservation of Giant Sequoia Forests in a Rapidly Changing World. Anthony Ambrose and Wendy Baxter have both done research here at Calaveras Big Tree State Park, and they gave a very interesting report 2.5 years ago, and then, everything shut down. So they're going to update and bring that up to information up to the current time. There's also going to be a giant sequoia seminar about John Muir and his relationship with the giant sequoias. That's May 7th. Now, the seminars themselves are free, but you need to pay to get into the park, and that's a $10 fee. So I want you to know that that's going on. Then there's also a fundraiser that will be happening later in May 14th, the Dogwood Festival. And that is a ticketed event, and we're selling tickets, and it will include things like a carriage ride. I know many of you have been missing those carriage rides from the Winter Wonderland that hasn't happened. A wine tasting, food, music. There's going to be a section for families to do crafts and engage children, all sorts of good stuff going on. Oh, by the way, in the family area will be free if you've already made it into the park. And when you buy your ticket in advance, and we need those advance tickets so we know how much food to fix, you get the entrance to the park is included in the ticket fee. So you will not have to pay at the entrance. So email questions or comments to cbta@bigtrees.org. And I thank you all very, very much, and hope to see you at future events.
Bye-bye, everybody. It's nice talking to you. I like the question. Thank you.
Thank you.
Great. Thanks a lot.